Welcome to our deep dive into the SAP HANA Hierarchy Developer Guide. In this video, we'll explore the essential concepts, functions, and practical examples you need to master hierarchical data in SAP HANA. Whether you're a developer, data architect, or just curious about how modern databases handle complex relationships, this guide will walk you through everything from basic terminology to advanced use cases. Let's get started by understanding what makes hierarchy functions such a core part of SAP HANA's platform and how they can help you efficiently manage and query hierarchical data structures. SAP HANA Hierarchy Developer Guide is organized to help you navigate from foundational concepts to advanced techniques. It starts with an introduction to hierarchy functions, then covers generating hierarchies, working with hierarchy attributes, and navigating hierarchical data. You'll also find sections on metadata views, comparisons with other SQL concepts, practical use cases, migration strategies, performance tips, and troubleshooting. This structure ensures you can quickly find the information you need, whether you're building your first hierarchy or optimizing complex queries. Hierarchy functions are a core part of SAP HANA, enabling native support for hierarchical attribute calculation and navigation. These functions let you perform typical hierarchy operations directly on relational data, integrating seamlessly with SQL queries. Hierarchy functions are especially useful for handling real-world data that's inherently hierarchical, such as company structures, categorized documents, or permission systems. By using these functions, you can efficiently query and manage diverse data layouts in a consistent, structured way. SAP HANA's hierarchy functions are designed to work with various source data formats, even if they're not explicitly structured as nodes and edges. The two most common types are parent-child hierarchies, where each record references a parent, and leveled hierarchies, where each record contains the full path through the hierarchy. These models allow you to represent everything from organizational charts to geographical data. The functions can handle different data types and even composite keys, making them flexible for many scenarios. Hierarchy model in SAP HANA separates creation from navigation. First, you generate a normalized hierarchy from your source data. Then you use navigation functions to traverse the hierarchy, finding ancestors, descendants, or siblings. This separation not only abstracts away the source data's layout, but also allows you to optimize performance and update strategies for your queries. The model supports both ad hoc queries and persistent hierarchy indices, giving you flexibility in how you manage and query your data. Real-world data rarely fits the ideal tree structure. SAP HANA's hierarchy generator functions are robust, handling deviations like multiple parents, cycles, or orphan nodes. They offer options to manage these cases, such as breaking cycles or adopting orphans, and retain information about the original topology. This ensures that your hierarchy can always be processed as one or more well-formed trees, making it easier to write optimized custom navigation functions for your specific needs. Understanding the terminology is key. In SAP HANA, a hierarchy is the result of a generator function structured as a tree or forest. Each node represents an element identified by its pre-order rank. Edges define relationships between nodes, with each node having at most one parent. Key terms include root no parent, child descendant, orphan unreachable node, and cycle loop in the structure. These definitions help you interpret hierarchy results and design effective queries. Let's look at a practical example using the T-demo table. This table defines a well-formed tree with nodes like A1, B1, B2, and so on. Each record specifies a parent-child relationship, making it easy to visualize the hierarchy. By running hierarchy functions on this table, you can generate a structured representation of the tree, complete with attributes like rank, level, and parent information. This example forms the basis for many of the guide's demonstration. Sometimes your data isn't perfect. The T-demo table includes trees with topology errors, such as nodes with multiple parents, cycles, or orphan nodes. For instance, node F6 is an orphan because its parent doesn't exist. These examples show how SAP HANA's hierarchy functions can detect and handle inconsistencies, ensuring you can still generate meaningful hierarchies even from messy data sources. Leveled hierarchies are another common pattern, where each record contains the full path through the hierarchy. The T-demo VL table demonstrates this, with columns for each level and attributes at different depths. This structure is useful for data like addresses, where you might have country, state, city, and street all in one row. SAP HANA's hierarchy functions can easily process this format, filling in any gaps and generating the complete hierarchy. Some hierarchies change over time. The T-demo time table includes validity intervals for each relationship, allowing you to build time-dependent hierarchies. This is especially useful for tracking changes in organizational structures or permissions over time. SAP HANA's hierarchy temporal function lets you query the hierarchy as it existed at any given point or interval, providing powerful tools for historical analysis. In some cases, node identifiers are made up of multiple components. The T-demo composite table shows how you can handle composite keys using SAP HANA's hierarchy functions. By concatenating multiple columns, you can create unique identifiers for each node, ensuring the hierarchy functions work correctly even with complex key structures. This flexibility is essential for integrating data from diverse sources. SAP HANA offers several hierarchy generator functions, each tailored to different scenarios. The main hierarchy function handles recursive parent-child data, while generates minimal spanning trees. Hierarchy temporal adds support for time-dependent data, and hierarchy level works with leveled source formats. The hierarchy composite scalar function helps manage composite node identifiers. Understanding when and how to use each function is key to building effective hierarchy. Hierarchy function is the most commonly used generator. Its syntax allows you to specify the source data, start conditions, sibling order, depth, multiparent policy, orphan handling, cycle policy, caching, and load strategy. Each option gives you control over how the hierarchy is built and how edge cases are managed. By adjusting these parameters, you can tailor the hierarchy generation to fit your data and performance needs. Using the hierarchy function, you start by specifying the source data. This can be a table, subquery, or function reference. Each row defines a parent-child relationship, and the columns must be named or aliased as node ID and parent ID. The data types must match and can include numeric, string, date-time, binary, or spatial types. This flexibility allows you to use the hierarchy functions with a wide variety of data sources. Start condition determines which nodes are considered roots in your hierarchy. You can specify this using the start where clause, filtering the source data to identify root nodes. If no start condition is given, nodes with a null parent are treated as roots. This feature lets you focus your hierarchy on specific subtrees or start points, making it easier to analyze particular segments of your data. You can control the order in which sibling nodes appear using the sibling order by clause. This overrides the original source order, ensuring your hierarchy is sorted as needed. The depth parameter lets you limit how deep the hierarchy traversal goes, which can improve performance when you only need part of the tree. These options help you fine-tune the hierarchy output for your specific analysis or reporting needs. Real-world data sometimes includes nodes with multiple parents. The multipart option lets you control how these are handled. You can accept all multiparent nodes, raise errors if they occur, or allow them only for leaf nodes. This flexibility ensures your hierarchy generation aligns with your data's integrity requirements and business rules. Orphan nodes, those not reachable from any root, can be managed in several ways. You can ignore them, treat them as new roots, adopt them under the last root, or raise errors if they exist. These options help you maintain a clean hierarchy structure and ensure that all relevant data is included or flagged as needed. Cycles, where a node is its own ancestor, can cause issues in hierarchies. The cycle option lets you choose to break cycles or raise errors if they're detected. By default, cycles are broken and the affected nodes are flagged. This ensures your hierarchy remains a strict tree, preventing infinite loops and maintaining data integrity. Performance is crucial when working with large hierarchies. The cache option lets you control whether the generated hierarchy is cached for faster navigation. The load option determines whether the entire source table is loaded or just the reachable rows. By tuning these settings, you can optimize performance for both ad hoc queries and repeated analyses. See the hierarchy function in action. Using the tdemo table, you can generate a hierarchy starting from the default root condition. The result includes attributes like rank, tree size, parent rank, level, and flags for cycles or orphans. This output gives you a complete view of the hierarchy, making it easy to analyze relationships and structure within your data. Sometimes you only need part of the hierarchy. By specifying a depth limit, you can restrict the results to a certain number of levels. For example, you might only want to see descendants down to level C. This feature is especially useful for focused analyses or when working with very large hierarchies, as it improves performance and clarity. You can customize the hierarchy by specifying different start nodes. For example, starting from nodes B1 and B2, you can choose to treat orphan nodes as new roots or adopt them under the last root. This flexibility allows you to tailor the hierarchy to your specific analysis needs, ensuring all relevant data is included in the structure. The hierarchy function also supports ancestor queries. By revering the node ID and parent ID columns, you can trace a node's lineage up to the root. This is useful for understanding the context of a specific node within the hierarchy, such as tracing an employee's management chain or a document's category path. If your data includes nodes with multiple parents, you can enforce strict policies using the multipart error or multipart leaves options. These settings raise errors if non-leaf nodes have multiple parents or if any multiparent nodes are found, helping you maintain data integrity and catch issues early in the hierarchy generation process. Alternatively, you can allow all kinds of multiparent nodes by using the multipart option. This is useful in scenarios where your data model permits nodes to have multiple parents, such as in certain organizational or permission structures. The hierarchy function will process these nodes as usual, ensuring all relationships are represented. Cycles can be problematic in hierarchies. By setting the cycle error option, you can enforce strict acyclicity, causing the function to raise an error if a cycle is detected. This is essential for applications where cycles are not allowed, such as strict organizational charts or category trees. If cycles are allowed, the default cycle breakup option will break the cycle and flag the affected node. This ensures the hierarchy remains a tree, even if the source data contains loops. The flagged nodes help you identify where cycles occurred so you can review or clean up the data as needed. Hierarchy SBNTRE function generates a minimal spanning tree from your source data. It's especially useful when your data contains multiple parent edges or cycles, as it only includes the shortest path between each start and result node. This function is ideal for connectivity testing, such as checking access rights or nested role structures, where you only need to know if a connection exists, not all possible paths. Using the tdemo table, the hierarchy SBNTRE function creates a spanning tree, ensuring each node is only included once per start node. This approach avoids exponential growth in result size and is much more efficient for large or complex graphs. It's particularly valuable when you need to test connectivity or build authorization checks in your applications. Hierarchy temporal function extends hierarchy generation to time-dependent data. By specifying validity intervals, you can generate hierarchies as they existed at specific times or over certain periods. This is crucial for applications that need to track changes over time, such as organizational history or permission changes. The T-demo timetable, you can use hierarchy temporal to build hierarchies for specific intervals or single points in time. For example, you might generate the hierarchy as it was on July 2, 2015, or for the period from 2011 to 2013. This allows for powerful historical analysis and auditing of changes in your data structures. Hierarchy-leveled function is designed for source data where each row defines a path through the hierarchy. This is common in address data or product categories. By processing these paths, SAP HANA can generate a complete hierarchy, filling in any missing levels and ensuring a consistent structure for analysis and reporting. When your nodes are identified by multiple columns, the hierarchy compositID scalar function helps you create unique identifiers. This is essential for hierarchies built from complex data sources, ensuring each node is distinct and the hierarchy functions operate correctly. By concatenating key columns, you maintain data integrity and avoid conflicts. Each node and edge in a generated hierarchy includes a set of standard attributes, such as rank, tree size, parent rank, level, root rank, and flags for cycles or orphans. These attributes provide detailed information about the structure and relationships within your hierarchy, enabling advanced analysis and custom navigation logic. Once your hierarchy is generated, SAP HANA provides built-in navigation functions to traverse it. You can efficiently find descendants, ancestors, or siblings of any node using optimized algorithms that leverage the hierarchy structure. This makes it easy to answer questions like, who reports to this manager, or what's the full path to this document? For more advanced needs, you can write custom navigation functions using the hierarchy's numeric attributes. This allows you to implement specialized traversals or queries, such as finding all nodes within a certain subtree or aggregating data across specific branches. The flexibility of SAP HANA's hierarchy model makes it easy to adapt to your unique requirements. SAP HANA provides metadata views such as hierarchy objects to help you manage and analyze your hierarchies. These views give you insight into the structure, attributes, and relationships within your hierarchies, making it easier to maintain and document your data models. SAP HANA's hierarchy functions are compared to related SQL concepts, such as with recursive common table expressions in SAP HANA Graph. While these approaches can also handle hierarchical data, the native hierarchy functions offer optimized performance, easier syntax, and more robust handling of complex scenarios like cycles and orphans. Hierarchies are everywhere in business data. Common use cases include organizational charts, product categories, document classification, and permission systems. SAP HANA's hierarchy functions make it easy to model, query, and analyze these structures, supporting both standard and custom scenarios. The guide includes practical recipes for advanced tasks, such as deriving additional attributes, working with unclean data, handling generic graph topologies, and creating synthetic test data. These examples help you tackle real-world challenges and make the most of SAP HANA's hierarchy features. If you're migrating from other relational database systems, SAP HANA's hierarchy functions provide a smooth transition. The guide covers strategies for adapting your existing data models and queries, ensuring you can leverage the full power of SAP HANA's hierarchy capabilities without losing valuable data or functionality. Performance is a key consideration when working with large or complex hierarchies. The guide offers recommendations for optimizing queries, managing cache and load strategies, and structuring your data for maximum efficiency. By following these best practices, you can ensure your hierarchy operations are fast and reliable. Finally, the guide includes troubleshooting tips for common issues, such as data inconsistencies, performance bottlenecks, and error messages. By understanding how to diagnose and resolve these problems, you'll be able to maintain robust, efficient hierarchies in your SAP HANA environment. In summary, mastering SAP HANA's hierarchy functions empowers you to manage complex data relationships with confidence and efficiency.